class. Today we're going to take a look at how to solve systems of inequalities. When you're doing that, you really are going to be graphing them, and your solution is actually going to be a picture. You'll notice that I have these two equations here, which are both linear inequalities, color-coded. This one's in red and this one's in blue. We're going to do them in the colors that correspond with them so that you can keep track of them when they're over here on our graph. Now, for this one here, we're going to take a look at graphing it. Remember that since this is a greater than and there's no equals underneath, that means that you're going to have a dashed line. Whenever you're graphing an inequality with a less than or a greater than symbol, you use a dashed or a dotted line. Whenever you have an inequality that is like this one with a line underneath it, that means that you include the values. So these two here will be solid lines. And so when we graph the inequalities, if you'll remember from your graphing chapter, the first thing you do is just graph the line, but you need to recognize that it's either going to be dashed or solid based on what the symbol is. So I noticed that this first equation here is in slope-intercept form. So I'm going to graph it just the way I would graph a regular line. However, because this does not have the line underneath it, I'm going to use a dashed line. Now, I notice since it's in slope-intercept form that this 5 down here would be the b. The b is where we begin. It's our y-intercept, which will be 0, 5. So since that's where we're going to begin, I'm going to go ahead and put a point there and label it as 0, 5. Now, to find another point, I'm going to use my slope, which is the value b multiplied by x, and move from this beginning point to another point. And over here, on the slope, the -2 is your rise. That means we'll go down 2. And the 3 is your run, which means we'll run forward 3. So we start at our y-intercept of 0, 5, and we go down 1, 2, and then we go forward 1, 2, 3. And we land right here at the point 3, 3. So we're going to go ahead and put a point there and label it 3, 3. If we want another point, we can continue and go down 1, 2 more and forward 1, 2, 3 more, and we land right here at the point 6, 1. Now, when we connect these, we need to remember we're using a dashed line. So we're going to go ahead and make a dashed line that connects our points. And there's our line. Now, we're not done yet, because if you'll remember, inequalities have a shaded portion to our coordinate plane. And we need to determine whether we want to shade over here or over here. And we determine which section gets shaded by using a test point. The easiest test point is the origin, which is 0, 0. So we're going to go ahead and test. And what I like to do when I'm solving this systems is completely graph one of them, including the shading, then completely graph the other one, including the shading, and where the solution is going to be is actually where the two overlap. So let's finish off this first one by testing 0, 0. Now I'm going to put 0, 0 right on here so we know where it's located in relation to our line. Now let's test our point 0, 0 in our red equation, or inequality. Our red inequality is this one here, plugging in 0 for the x and the y. We get this cancels, and we're left with 0 greater than 5. And this is a false statement. Since 0, 0 is located over here, this whole side is false, which by default makes the other side over here true, which means that when we shade, we're going to shade this side here. Now, that is our red one completely finished. That doesn't mean that everything we have on here is going to be part of our solution. It just means that that's what the red one looks like if it's all by itself. Now let's move on to our blue one since the red one is complete. Because of this symbol here, we're going to have a solid line. And since this happens to be in standard form, I'm going to graph it using x and y intercepts. So I'm going to make a table, and we're going to plug in 0 for x to find the y-intercept, and then 0 for y to find the x-intercept, and then plot those to figure out where our line is. So now I'm going to start with plugging in 0 for the x, and I'm going to ignore the inequality for right now. We know from that inequality we're going to use a solid line. So I end up with 2 times 0 minus 5y equals 10. This goes away when I divide by negative 5. The y is negative 2. So this will be negative 2, and I have a point 0, negative 2. Let's go ahead and plot that. It lands right here at 0, negative 2. Notice I'm going to completely ignore the red one while I'm putting the blue one on the graph. Now let's plug in 0 for our y. We get 2x minus 5 times 0 equals 10. This goes away, and I have 2x equals 10. Divide both sides by 2, and the x is 5. So I have a 5 here, which is the point 50. If I plot that, it lands right here. We know from the inequality here that we will connect these with a solid line, and that is the line for the blue one. But I'm not done. I need to shade my blue inequality. So I'm going to go ahead and remove some of this so I have some room. And we're going to test an easy point in this inequality to see where we shade. And notice again 0, 0 is located right here. And as long as the line does not go through 0, 0, we can use it to test. So I've labeled it, it's on this side of the line. If we get a true statement for over here, we'll shade this side. If we get a false, we'll shade over here. So now let's go ahead and test 0, 0 in the blue inequality. I get 2 times 0 minus 5 times 0 less than or equal to 10, or 0 less than or equal to 10. This is true, and it's located over here, so over here is true for the blue one. So for blue, we're going to shade everything over here. Notice that our two inequalities overlap in this corner up here. This overlapping section is where the solution is. So for writing our answer, we actually want to take away this shading, take away this shading, which we have a little bit more of, and then just shade the corner, because that's the only part that is part of our line. I'm probably not going to get that shading there. So let's go ahead and make our answer in black. Our answer in black is going to include this solid line here. It's going to include the dashed line right here. And then the spot where the two overlapped was up in the corner here. So we're going to shade everything in just this corner. So what we have for our strategy on this is to graph each separately and then look where they overlap, and that overlapping section is the solution. Another way that you may see for how to solve this is to graph both lines and then actually find a test point for all 4 sections to see which one gets shaded. That works fine too. It's just up to you as to what your preference is. I like to graph one, shade it, graph the other, shade it, and then make the overlapping part our solution. Graphing both lines and then testing a point in each of the four areas to find out which one's true for both equations is fine also. That is how you solve systems of inequalities. Just basically graph both of them, see where they overlap, and that is where your solution is.